Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So in our today's lesson, we will discuss about the ionic radius and its periodicity, that how the ionic radius variate in the periodic table. So first of all, you guys must know that what does mean by the ionic radii. Ionic radii basically corresponds to the radii of the ions, that what is the radius of the ions in the ionic crystals or in ionic compounds. So basically the definition of ionic radius we have, it may be defined as the effective distance from the center of the nucleus. For example, here we have an ion, cation or anion. So what will be the effective distance of the nucleus towards its the electronic cloud? So this distance will be known as its ionic radius. Basically, when we have an atom in its neutral state and we are going to remove the electron from it, it changes into the cation, and cations are basically positively charged ions. So an atom is bigger as compared to the cation. Now, what is the reason? There may be the two reasons. The first one may be the electronic shell is removed so that the size of an atom decreases. On the other hand, as the number of electrons in the outermost shell decreases, so the nucleus attract the electrons more tightly. So the force of attraction between the electrons and the nucleus increases. In turn, the size of an atom also decreases. So atom is bigger in size as compared to the cations. We can also have an example for this. For example, here we have a sodium, and when we remove the electron from it, it changes into the positively charged cation. Here the sodium atom, its size is almost 157 picometer. But when it changes into the sodium cation, now its size is 95 picometer. So there is a decrease in the atomic size, ionic radius of an cation. But on the other hand, when we have a look on the ionic radii of the anions, and anions are basically negatively charged cations. Here we have an atom and we just add up an electron. So its size of anion, it will be increased. Now why the size of an anion increase? Because we just add an electron. There may be the reason a new electronic shell will be added. So that's why the size of an anion will be bigger as compared to the simple atom. We can also have an example for this purpose. We have a fluoride or fluorine atom. Its size is basically 72 picometer, and we just adds up an electron in it. After the addition of electron, it changes into the anion. Now that anion is having the size of 136 picometer. So there is an increase in the ionic radii or the size of the ions. Next, let's discuss the variation or the trend of the ionic radius along the group. So in group, when we move from top to bottom, or when in periods we move from left to right, we just observe that the similar charged ions increases in size. Here along x-axis we have just take the elements, and along y-axis we have just taken the ionic radii, that is in 10 raised to power minus 12 meter. So here the first one we have helium. Its electronic configuration is 2s2 2p6. And electronic configuration of helium is 1s2. Then we have 2s2 2p6. Total number of electrons we have, it's 10. And then we have an element whose electronic configuration started from this. First one is sodium 11, then magnesium 12, aluminum 13, silicon 14, 15, phosphorus and 16, and sulfur and 17 at chlorine. Here, the atomic size gradually from left to right decreases and then it started to be increase. This just happened in the period. But when we move from top to bottom, we just looked at, for example, we have lithium, it lose its first shell. Then we just see that the sodium, it was having first three shells, then by losing one, it has two shells. So there is a simple or gradual, we can see that the decrease, but in a regular manner, there is a size is no change because size is going to be increase in a periodic manner. So in groups, basically the similar charge ions increases in size. Similar charge ions means there is a formation of cations formed by the loss of electrons. When they lose the electrons, there is a formation of cations and they are having similar charge. So this is the very simple trend from top to bottom in the group. But on the other hand, when we move from left to right in the periods, we just see that they show they are decrease in the ionic radius. In ionic radius. So what is the reason behind that when we move from left to right that there is an increase? The same trend is observed in isoelectronic negative ions. Isoelectronic negative ions. What does mean by the isoelectronic negative ions? Isoelectronic, that is having charge. Negative means they are having negative charge. This is just because they increase in the nuclear charge. When you move from left to right, there is an increase in the nuclear charge, and the nuclear charge we have, it is the charge on nucleus, which is positive charge. When the positive charge on nucleus increases, it pulls the electrons more tightly towards itself. In turn, the size decreases. So the variation in atomic and the ionic radii of the alkali metals towards the halogens, it can also be shown in the figure or by drawing a simple ionic radii graph. Let's have a graph in which we are having x-axis and y-axis. And along x-axis we are having the atomic number of the halogens. It is 9, 17, 35 and 53. And along y-axis we have their atomic or ionic radii from 50, 100, 150 and so on. So we just see that there is gradual increase in the size. Means fluorine, we have chlorine, bromine and iodine as their ionic radii increases. This is the trend in the groups. But when we move from left to right in the period, so ionic radii decreases because when we add an electron in their outermost shell, so there is a repulsion between the electrons that are already present in the shells and the added electrons. So that's why the nucleus pull these electrons more tightly. In turn, the size will be decreases. So this is a simple trend across the period and the group. I hope you guys understand about the topic, and if you have any queries, you may ask me about that in the comment section. And the next topic that we will discuss, it is the oxidation state. For that time, you guys have a good day and keep learning.